This is the story of what happens when the world's most ambitious industrialist decides the global semiconductor supply chain isn't moving fast enough, and announces he's going to build his own. On the evening of March 21st, 2026, Elon Musk stood inside the defunct Seaholm power plant in Austin, Texas, and officially launched what he called the most epic chip-building exercise in history by far. What he announced that night, why he says it has to happen, and why some of the smartest people in semiconductors think it might be the hardest thing he's ever attempted. Start with the scale of what's being proposed, because this is not a modest project. The Terafab is a joint venture between Tesla, SpaceX, and xAI, Musk's artificial intelligence company, which SpaceX folded into itself as a wholly owned subsidiary back in February of 2026. The facility will sit on the Tesla campus in eastern Travis County, just outside Austin, next to the existing Gigafactory, Texas. Its stated goal is to produce 1 terawatt of computing power annually from a single location, and the cost, according to reports tied to the announcement, sits at $20 billion. What makes the facility different from anything currently operating is the architecture Musk described. Every stage of semiconductor production, logic chips, memory chips, packaging, testing, mask production, and design iteration would all run under one roof in a continuous feedback loop. Musk put it plainly, to the best of his knowledge, nowhere on Earth currently houses everything needed to build logic, memory, handle packaging, run tests, produce masks, refine those masks, and keep looping that process in a single integrated system. That vertical integration is the core of what he's selling. 2 chip families are planned for the facility. The first carries the name AI5, optimized for edge and inference computing. The chips that power Tesla's vehicles, the robotaxi network, and the Optimus humanoid robot lineup. The second family, unveiled at the event, is called the D3, and these are purpose-built for deployment in space, engineered to function in the kind of orbital conditions that would destroy a standard consumer chip. And that second family, it turns out, is not a footnote. It's actually where the majority of the factor's output is headed. The announcement didn't arrive without context. At Tesla's annual shareholder meeting in November of 2025, Musk first put the concept on the table publicly, and his framing was direct. Even when you extrapolate the best-case scenario for chip production from every existing supplier, it still falls short. His words at that meeting were, "I cannot see any other way to get to the volume of chips that we are looking for, so I think we are probably going to have to build a gigantic chip fab. It's gotta be done." By January 28th, 2026, the language had hardened further. On Tesla's Q4 earnings call, Musk told investors the company needed a domestic fabrication facility to head off a supply constraint he projected arriving within 3 to 4 years. And his formulation left little room for interpretation. We either build the terafab or we don't have the chips, and we need the chips, so we build the terafab. The numbers driving that urgency are worth sitting with. Musk's companies need somewhere between 100 million and 200 million AI chips just for Earth-based applications, full self-driving systems, Optimus robots, the robotaxi network. That translates to roughly 100 to 200 gigawatts of compute per year, and current global fabrication output, according to KXAN in Austin, represents only around 2% of what Musk says he needs. At the Seaholm event itself, he acknowledged the suppliers he currently relies on, and his words were careful. "We're very grateful to Samsung, TSMC, and Micron, but there's a maximum rate at which they're comfortable expanding, and that rate is much less than what his companies require." None of that gratitude changes the math, which is why the Terafab exists alongside those relationships rather than replacing them in the near term. Here's where the story takes a turn that most of the initial coverage underplayed. Roughly 80% of the Terafab's planned output isn't destined for Earth at all. SpaceX filed a petition with the FCC in January of 2026 for licenses to launch a network of 1 million data center satellites, Orbital AI infrastructure designed to run Musk's systems from above the planet. The D3 chip is the hardware backbone for that network, and the Terafab, built on the ground in Austin, is where those chips get made before launch. Funding that ambition is one of the forces driving SpaceX's planned IPO this summer, which analysts at Bloomberg project could raise as much as
$50 billion and value the company somewhere between $1.5 and $1.75 trillion, depending on which report you read.
No honest account of this story skips what follows, because the reasons for doubt here are substantive. Start with the talent situation. Building a world-class semiconductor fab requires engineering depth that takes decades to accumulate. And in the years leading up to this announcement, Tesla shed 3 of its most senior chip architects. Jim Keller, whose processor design work spans some of the most celebrated chips in industry history, left Tesla back in 2018. Ganesh Venkataramanan led the Dojo supercomputer project until late 2023, when he departed to found his own startup, Density AI. Peter Bannon, Tesla's silicon architect, walked out the door in August of 2025, and roughly 20 Dojo team members followed him. That Dojo situation deserves its own paragraph because the timeline is striking. Tesla had invested heavily in the Dojo supercomputer project, only to shut down the entire team in August of 2025 after Musk posted on X that Dojo 2 had become an evolutionary dead end once all paths converged on a new chip architecture called AI6. Less than 6 months later, in January of 2026, the Dojo name resurfaced, rebranded for space-based compute in conjunction with SpaceX's orbital plans. Whether that counts as a pivot or a contradiction depends on your read of Musk's track record. And that track record is a legitimate variable here. At Tesla's Battery Day in September of 2020, Musk put a number on the table: 100 gigawatt hours of in-house cell production by 2022. By early 2025, Tesla's actual 4680 battery production was running at roughly 20 gigawatt hours per year, less than a quarter of the target. He also promised a $25,000 Tesla at that same event. Neither arrived on schedule. The most pointed external criticism, though, came from Jensen Huang. During a visit to Taiwan in November of 2025, NVIDIA's CEO described building advanced chip manufacturing as extremely hard, not just constructing a building, but mastering what he called the engineering, the science, and the artistry of what TSMC does for a living. Pushed further, Wang told reporters that matching TSMC's semiconductor capabilities is, in his word, virtually impossible. Wang doesn't say things like that carelessly. Intel serves as the cautionary data point here. A company carrying thousands of experienced fab engineers with over $100 billion committed to manufacturing investments has spent years grinding to recover its edge against TSMC. The difficulty Musk is stepping into isn't theoretical. Intel has been living it publicly for most of this decade. One more technical wrinkle gets raised by experts who follow semiconductor production closely. The actual bottleneck in advanced AI chip production, some argue, isn't fabrication capacity at all. It's a process called CoWoS, chip on wafer on substrate, the advanced packaging step that connects chips together for deployment. NVIDIA alone holds over 70% of TSMC's CoWoS-L capacity. A fabrication plant, however large, doesn't automatically solve a packaging constraint. Bloomberg noted plainly in its coverage that Musk carries no background in semiconductor production, a statement of fact that belongs in any complete account of this project.